Hi everybody, this is Mr. Bowman, and in Chapter 3 we're going to learn a whole bunch of derivative rules or shortcut rules so that we don't have to use the limit definition and an algebraic approach every single time we want to find a derivative. So we're going to start off with some simple functions. They're all constants, and to illustrate the derivative of these constants, we're going to jump over to Desmos and look at a graph of them. Remember, a derivative is the slope of the function. And so if we jump over to Desmos, we've got these four functions here. They're all constants, and you can see that at any point, at any x value on these graphs, their slopes are zero. So we just established the first rule of derivatives, that the slopes of constants are zero. G prime of x is equal to 0, h prime of x is equal to 0, j prime of x is equal to 0. So d dx of a constant c is equal to 0. For the next rule, we're going to take a look at what's called the power rule. So I'm going to show you some derivatives, and while I'm doing that, see if you can come up with a pattern. So the derivative of x is equal to 1. The derivative of x squared is equal to 2x. The derivative of x cubed is equal to 3x squared. And we're going to keep going with that. The derivative of x to the fourth is equal to 4x cubed. The derivative of x to the fifth is equal to 5x to the fourth. And we'll do one more. The derivative of x to the sixth is equal to 6x to the fifth. So pause the video for a minute and see if you can figure out what the rule is for the derivative of x to the n. If you said the derivative of x to the n is n times x to the n minus 1, then you are correct. For this next rule, we're going to take a look at what we call the constant multiplier rule, and you can graph these functions on Desmos and see how their slopes are related, but f of x has a slope of 1, so f prime of x is equal to 1. G of x has a slope of 2, so g prime of x is equal to 2. And h of x has a slope of 3, so h prime of x is equal to 3. And then finally, j of x has a slope of negative 7, so j prime of x is equal to negative 7. And the rule that establishes for us is the following, that the derivative of a constant times f of x, which is actually what g of x, h of x, and j of x can be thought of, is the same as the constant times the derivative of f of x. So for example, you could see that j of x is equal to negative 7 times f of x, negative 7 f of x, and therefore the derivative of j of x is negative 7 times the derivative of f of x. So literally you can factor a constant out before you take the derivative of a function. And we are going to finish up the rules in this lesson with the sum difference rule. So the derivative of a sum of two functions or a difference of two functions is equal to, well, we're basically using the properties of limits here because derivatives are limits, and we're saying we can split this apart into the separate derivatives. So we can take the derivative of f plus or minus the derivative of g. So we're going to finish up this short video with an example, and this pertains to maintenance costs. Table 3.1 gives the maintenance costs for vehicles driven for 15,000 miles in the United States from 1993 through 2000. The maintenance costs given are yearly averages. So G of t represents the maintenance cost. T represents years since 1993. And our function is a quadratic function. G of t is equal to 4.554 t squared minus 0.625 t plus $366.875, where t is the number of years since 1993. The data range from t values of 0 to 7, and there's a graph of that function up there. Write a rate of change model for the maintenance cost model. In other words, part A is saying, find the derivative of t. So we're going to use a couple properties here. We're going to use the power property, we're going to use the constant property, and we're going to use the sum difference property. So g prime of t, we're going to take the first part. The constant 4.554 can be taken out. Take the derivative of t squared, which is just 2t. So we have 4.554 times 2t to the first power, which we can write that in, but typically it's dropped, minus the 0.625 is a constant, so we can take that out and multiply that by the derivative of t to the first, which is just 1, and then we can take the derivative of the constant, which is 0. So there is our derivative. Typically that would be simplified, and we would write that as 2 times 4.554. So what would that be? That would be 9.118 t minus 0.625. Excuse my mistake here. I realized I said 9.118. I should have said 9.108. In part B, it asks us to use the rate of change model to approximate how rapidly maintenance costs were increasing in 1998. So there's a clue there. How rapidly, basically, we need to find the rate of change in 1998. But it also said increasing, so that implies that our derivative should be positive. So g prime 1998 would be 5 years after 1993, so g prime of 5, and if you plug that in, you're going to have 9.108 times 5 minus 0.625, and if you verify, that turns out to be approximately $44.91 per year. And that's it for the first lesson on derivative rules.